I've tested this already, so
Yeah, it's not too bad a software, I suppose.
no. And there we go. So that's us. We're ready to start.
Okay, so I'm gonna do the first part and then you do from UDP then, yeah?
Yep.
Yeah. All right, so um is there a slide before this or not? The like intro
Oh,
slide?
there we go.
Can't
Sorry.
remember what it was called. Yeah. No, I wasn't too sure. Hi everyone and welcome to this week's Cybercamp webinar. This week our webinar is focused on TCP versus UDP. So today's our webinar will be delivered by myself, Nicole, and Bryony. And then it has been supported by Elaine and also Elizabeth and Andrew. Okay, so looking at TCP and UDP, what exactly are they? Okay, so TCP stands for Transmission Control Protocol, and then UDP stands for User Datagram Protocol. So is one better than the other, or what is our thoughts? Are they used for different tasks? That's things that we are going to discuss in today's session. Okay, so firstly, looking at TCP, it is a core protocol really that is used within the Internet Protocol Suite. So if you've maybe heard of the TCP/IP protocol suite, it will be used in that on the transport layer. It does provide reliable and orderly transfer of data over a network, and does have a number of different benefits. Okay, so benefits include the likes of your connection orientation, and that's really allowing it to connect or be connected in an orderly manner, meaning that its logical connection can be established between the sender and the receiver, and the data before the data is exchanged. Both parties are ready to for the communication, and it really allows efficient data transfer. It is reliable, and that does mean that it's reliable and it is error-free communication, and it does this through sending acknowledgements, and retransmissions where required. And the TCP requires the receiving and to acknowledge the recipient. And if an acknowledgement is not received, this is where the retransmission will occur, helping reduce the risk of data loss. Flow control, so it does incorporate flow control, and this allows it to manage the rate at which the data is transmitted between the sender and the receiver. So it prevents the sender from overwhelming the receiver, and preventing congestion and ensuring that data is processed manageably. And then error detection and correction. So it does include error checking methods to detect any data corruption during the transmission. And so if an error is detected, it can request retransmission of the corrupted data, and it ensures that the information is sent accurately. And then full duplex communication. Okay, so that does support full duplex communication, meaning that data can be transferred or transmitted in both directions simultaneously, which is essential for interactive applications. Okay, so when exactly do we use TCP? It is used whenever we need reliability, order and error checking of the delivery of the data. So a number of different applications that does use TCP includes web browsing, all right, and this may include both protocols, HTTP and HTTPS, so your hypertext transfer protocol and then also your hypertext transfer protocol secure, and they are used whenever you're using a web server to view any files on the internet. Your HTTPS, it actually incorporates a secure mechanism, all right, and that is including a layer of encryption, and it is either TLS or SSL, which is your transport layer security or your secure socket layer. And that does help ensure the confidentiality and integrity of the data that is being transmitted. So if you are transferring any data over the internet, whether it be maybe personal data, completing any online forms, for example, you do want to ensure that it is using HTTPS rather than HTTP. It TCP is also used within emails, and there is a number of different protocols around email. So you have the likes of your simple mail transfer protocol, and that's used for sending emails over the internet, and then also your post office protocol, version 3, which is currently used, and really it's used for receiving emails, and they do operate over your TCP. And then we have file transfer protocol, and that is used for transferring files from one host to another over a TCP-based network. And it does ensure that files are transmitted reliably and in the order that is required. It is also used on a number of other internet-based services, such as database connections. So, for example, MySQL, your secure shell, as well. And Windows would also use it on the remote desktop protocol also. Okay, so how does TCP work? As we've mentioned, it is connection orientated. All right, so to do this, it does have a three-way handshake, and it's the process that occurs when two devices establish a TCP connection. And really, the process does involve 3 steps, and it is crucial, really, for setting up your reliable and orderly communication over the network. So as you can see, there's a SYN, ACK, and ACK. And this is actually the 3 steps that TCP performs. All right, so the first step will be SYN, and really that is your synchronize. And the process really begins when your client sends a TCP segment with the SYN flag to the server. And then the segment is then the initial request to establish that connection. Then the second stage, which is your SYN-ACK, and that stands for your synchronize acknowledge. And once the server receives a SYN segment, it will respond by sending a TCP segment with both your SYN and ACK flags set. And then the acknowledgement number is set to the client's number +1, which indicates that the server is ready to receive data from the client. And then you have ACK, which is the third stage, and that's just your acknowledge. So the client acknowledges that the server's response by sending a TCP segment with your ACK flag set, and then it does send back the acknowledgement number to the server with their number +1, and that is indicating that the client is ready to send that data. Okay, so with your TCP three-way handshake, it does ensure that the client and the server are both aware that there is communication about to occur and that they are ready for that connection and for the information. It does ensure that it is sent in an orderly format, and it is connection orientated. Okay, so as we've mentioned, really with TCP, we've talked about how they set up the connection to begin with, and it does ensure your acknowledgements. It does have your sequence numbers, your flow controls, and your error detection and correction. However, once data has been sent, they do want to also terminate that connection, and again, there is another process that's done to do that. So it is really ensuring that all the data has been reliably exchanged before the connection is closed. The termination process does have a 4-step process. Firstly, they want to initiate the closure, and this is done through sending a FIN flag to the device, and that's signaling the intent to close the connection. Next step would be the acknowledgement of the closure. And this is again sending an acknowledgement back, initiating that they are confirming to close. They have received the fin flag, and then initiating the closure on the other end. Receiving device will acknowledge the fin and also decide to terminate that connection by sending a fin segment as well as the acknowledgement. And then finally, the acknowledgement of your second closure, and that is sending an acknowledgement back to say that it has now been closed.
UDP now. So Nichole's explained TCP, which is slightly more complex than UDP. UDP's simple. It doesn't really care. It's a bit like, I think, talking to my teenagers. I can talk to them and I never get any response back. Don't know if they've received it or understood it. So it stands for User Datagram or Datagram Protocol, and it is connectionless, which means that it just chucks the information out there and hopes it gets there in the end. Which means it's unreliable because we get nothing back to say whether we've had it or not, or whether it's been sent or lost. But that means it's got a low overhead. So that's less stuff attached to the information that's been sent across the network, which makes it a little bit easier to send. We're not going to have as many bottlenecks. With that, it means it's simple. It doesn't need all the added extra flags. It doesn't need the initiation of the session to begin with. And unlike TCP, it allows us to send messages to more than one person or one host or one device or one element at one time, because it allows for broadcast and multicast. It means you can send somebody something more than once. You don't have to send it individually to all the people. Sorry, wrong button. No, it's not changing. So we use this with real-time transmissions. So really important things like online gaming and video conferencing and streaming, what we're doing just now. Because it doesn't guarantee the delivery, it means that if you're using an application that you need to have confirmation and you need to have error checking and flow control, that application would have to implement that itself. Because as I said, UDP will just send that information out there and fingers crossed that it gets there at the other end. It doesn't have a handshake process. It sends the data packets, which are called datagrams, from the sender to the receiver, A to B, without anything. No error checking, no flow control, no acknowledgements. Which means it's faster because it doesn't have any of those added features. Lower overheads, quicker, nicer, you could argue, easier to implement, and it just works. But you don't have that guarantee that the package is getting there or the datagram at the end. You have no idea. You're sending it and hoping for the best. And a little summary between the two of them, just as a wee reminder, UDP will just send the messages. So in the diagram, a couple of messages have sent, but that last one has been lost. But you wouldn't know. You won't get any feedback on that. Whereas with the sender and the receiver with TCP, we have that three-way handshake to begin with before any information is sent, and then it's closed at the end as well. So it's a dedicated connection. Anything else to add, Nichole?
No, I don't really have anything to add to your summary, no.
And
I think
that's
you've
us for
covered all on UDP.
Yeah, that's us for TCP and UDP. There's not much to it really. Two nice little protocols that just work. And that's us for this week.
Okay, bye bye.
Thanks.